Hi and welcome to the first lesson in the Subroutines series. This lesson is called Introduction to Subroutines. Objectives of this lesson. We will discuss the advantages of breaking our code into smaller pieces. In addition, we will show a first attempt of breaking our code into smaller pieces. Managing large code. As our code becomes longer, it could become harder to manage. Maybe so far you haven't encountered this problem because the code that you have written or the code that you have read was pretty small. We only solved some pretty small problems or dealt with some pretty simple tasks. We didn't do a very complicated project. But as your code becomes longer, it could become harder to manage it if you don't have the right tools. We want our code to have the following properties. The first one, easy to develop, which means that it should be pretty easy to write the code. Usually, even if you write the code the way we have learned so far, it should be easy. However, the problems begin when you work with a group of people. We want to be able to somehow divide the job of writing the code to more than one person, and then finally being able to take all the results from all the people who worked on a project and merge all the results into one working program. And this is a challenge. This is not always easy to do. Second, we want our code to be easy to understand. Some pieces of code are so large and complicated that no one human being can perceive the full complexity of the system. And there are many examples of these kind of systems. For example, maybe operation systems are so complex that there is no one human being that can understand the full complexity of the operation system, for example. We want to be able to somehow manage with very large pieces of code. We want to be able maybe to understand only one part at a time, for example. Another important property is readability. We want our code to be easy to read, even for people who didn't write the code, or maybe people who didn't participate in the project. We want people to be able to look at the code and have some general feeling of what it does, even without understanding every detail. Finally, we want our code to be easy to maintain. Basically, it means that we want to be able to make changes such that it won't be a very hard process. Changes could be done easily. In addition, we want that bugs or mistakes could be traced easily, which means that if there is some problem inside the code because some of the programmers has made a mistake, we would be able to find it easily. A common solution to those requests would be to break our code into smaller pieces. Each piece of code will have a specific purpose, and we are going to call each piece a function or a subroutine, which is basically the same. These are just different names for the same thing. Sometimes people also call it a procedure. We are mostly going to use this name, function. After we divide our code into smaller pieces, whenever we read the code, instead of thinking about the instructions, the assembly instruction, we could think about functions. Basically, we abstract away the internal details of a function. So, we only care about what the function does, instead of how does the function work, or how does it do it. And by this abstraction, we don't lose anything. we could always dive into the details of the how if we wanted to. You have already seen and used some functions. For example, read hex, print EAX, and read line. Yes, those are three functions that you have already used yourself. Note that you have managed to use those functions without knowing exactly how they work internally, which is some kind of a miracle. So let's begin with the first attempt of creating our own function. This is only a first attempt. This is not how it is done usually in the x86 architecture. But we are going to try to utilize everything that we know so far, everything that we have learned so far, to try to create a function. This is just an attempt to do it. We begin with an example. We want to find all the prime numbers between 1 and n, where n is some given input. For example, maybe the user gave us the number n. I remind you what is a prime number. A prime number is a number that is only divisible by 1 and by itself. Some examples for the first prime numbers: 2, 3, 5, 7, 11, and 13. Basically, we are going to write a function which we are going to call isPrime. Given a number in EAX, the function isPrime is going to return one of the following. EAX equals 0 if the number is not prime, and EAX equals 1 if the number is prime. This function gets its input inside the EAX register, and the output will also be inside the EAX register. Finally, after we write this function, we will be able to invoke it inside a loop. We are going to iterate for every number between 1 and n, and then we are going to set EAX to be the current loop number, the current iteration number, and we are going to invoke the isPrime function. So we are going to have two parts of code. The first part of code is going to be the implementation of isPrime, which is going to deal with prime numbers and divisibility and things like that. And the other part is going to be a pretty simple loop that just iterates, and every time it calls to isPrime to check if the current number is a prime number or not. This is an example for the isPrime function. You don't have to get into the details right now. You will be able to read this code in your favorite editor in a file later. I've prepared a file that contains this implementation if you are interested in how it really works. But currently, we don't really care about the implementation. We only care about the general structure of the thing. We can see that we have this label, isPrime, which marks the beginning of this function. And this is the actual function. We can see that it gets EAX as input. It assumes that EAX contains some important information. And finally, in the end, it sets EAX to be the result. We only care about the following. This label isPrime, the input, which is EAX, and the output, which is EAX. We can really summarize it this way. We have some kind of function which is called isPrime, and this is what it does. It checks if EAX is a prime number. If it is, we return EAX equals 1. If it doesn't, this function returns EAX equals 0. Now that we have this function, we really care about how to use it. How can we invoke this function and get a result? This is a very simple example of using isPrime. We are not even going to iterate over it. and check all the numbers between 1 and n. I only want to show you a very simple example of trying to find out if this number is prime. We have a strange number here, 13453 in base 16. And we want to check if this number is prime. Let's first check out the general structure of the code. We have this push 0 and call exit process, and this part basically exits the program. We put this function is prime after the part which exits the program. We did it to make sure that we don't slide into this code. We don't want to execute this code after we finish with this program. This is just a subroutine. We want to invoke it only at a certain time. We have this part as a separator. This is our main code. The execution begins here at the move instruction, and this is the is prime subroutine. We begin by loading this number into EAX, which marks the input for the is prime function, and then we jump to is prime, which means that we are going to jump here. Then lots of code is going to execute here, which is going to decide somehow if the number which we have given, which is currently this number, is prime or not. And then we are going to have a result inside EAX when we jump back. This is basically the flow of calling a function or invoking a function. We first jump to the first instruction in the function, and finally when the function ends, we jump back to where we came from. Maybe if I say it in a more exact manner, we come back to the next instruction after the jump. So basically, we first do this jump, then we execute all the code here, and then we jump back to this test instruction. If you think about it from the point of view of someone who only sees this part of the code and doesn't look at the is prime function, he only cares that this function is being called and later the execution returns here to the next instruction. This is some kind of abstraction mechanism. It hides the contents of is prime, and it hides the way that is prime works. The reader of this code doesn't have to see it. It just knows that after we jump to is prime, eventually we are going to come back here with a result. Then we can just test the result to check if the number was prime or not prime. As we can see here, we have a simple if construct. We get to this clause if the number is prime, and we get to the other clause here if the number was not prime. Finally, we exit the program. I remind you that this part makes sure that we don't execute the is prime subroutine again. It serves as a separator. Let's discuss some pros and cons of this method. We begin with abstraction. As we said before, the author or reader of the code on the top, which is here, doesn't have to know much about primes. He just has to know that he should call this function is prime, and then he's going to get a result. He doesn't care how it happens. He just knows that it is going to happen. In fact, it might be true that this code was written by two different people. One person wrote this function, which is called is prime, and the other person wrote this part of the code. Maybe one of them is a mathematician, and he knows a lot about primes. So it was reasonable that he's going to write this function, isPrime. And the other guy knows about other stuff. Maybe he knows about low level of the operation system or some other subject. And he uses the work of the mathematician in his code. He doesn't have to know anything about primes. He just has to be able to call this function and get a result. Another advantage is readability. The code on the top is pretty easy to read, mostly if you don't know anything about primes. You can just see this name isPrime, and you can conclude that this is a primality test. You can conclude that we just test if this number is a prime or not. But imagine how the code would look like if all the internal instructions of the isPrime function would be pasted here instead of those two lines. It would make the program hard to understand. But now that we have this separation, the code is much easier to read. Another advantage is that this code is easy to change. For example, if we found out a better way to check if a number is prime, here we used a pretty naive method of checking out if a number is prime or not. There are many better ways to check if a number is a prime. Maybe at some time during the development process, we found another way. Changing the code is going to be simple. We just change this part. We don't have to change anything about the other piece of code. We just have to change the code on the bottom, the implementation of isPrime. However, this example or this first attempt of creating a function is far from being perfect. There are some major cons to this simple jumps method. I remind you that we have just used 2 jumps to implement this, and it has some serious disadvantages. Maybe the first one, which is a major one, we can only invoke the isPrime function from one place, because we have this jump to this specific label after isPrime. So we can't call this function isPrime from a different place. We have to do it here because this is where the label after isPrime is located. This is not really cool. We want to be able to call our function from many places in our code. But here we can't do this. We can only call it from here, from where the after isPrime label is at. Another disadvantage is related to the first one. We have to add this label, which is pretty ugly in my opinion. I don't want to have this label in my code, especially not every time that I call isPrime. The last disadvantage is that isPrime changes the contents of the registers. Let me remind you how isPrime looks like. This is how it looks like. Note, for example, that it changes ESI, ECX, and also EDI. And finally, it also changes EAX, but maybe this is something that we have expected. So, we could have some problems because we don't have so many registers. This is something that we will probably deal with in the future. We will see how to deal with it. So our first attempt was rather crude. However, we have already achieved some advantages using it. We want a better solution for function mechanism. Don't worry, this is not what we are going to settle for. We want something better. After we've seen this example, we know about some other wanted features. The first one is being able to call our functions from anywhere in our code. The second one is that we want a function that won't change the registers, or at least won't change most of the registers. Maybe we do want to change some of them, but not all of them. Summary of this lesson. We have seen that breaking our code into smaller functions makes it easier to understand and maintain. We have also seen one attempt of breaking our code into smaller functions, which was only partially successful. But don't worry, in the next lesson we are going to see a better functions mechanism. Some further code reading. I believe that you might want to read the contents of the isPrime function to understand how it works. And in addition, remember that we wanted to find all the prime numbers between 1 and n. The code that does this task was a bit too large. I think that it is better if you read it yourself. At this point, it should be pretty easy for you to read it because we have gone over how we call the isPrime function. So take a moment in the end of this lesson and read isPrime.asm and make sure that you understand how it works. See you next time.